Hello everyone, I'm Mohit and I'm going to represent how we can find a unique element in the array using the 8085 programming. So this is my submission for PHN 314. Let's get started. First we will see what are the contents of our presentation. We are given a size n array and the next n memory locations will be storing the elements of array in our GNU simulator. The algorithm we will be using is nothing but simple logical operation XOR. We will be using this and we will see it in the next slides. The software we are using here is GNU Simulator 8085, and finally we will be seeing the code, how we can code and how we can get the unique element from the array. So the array is with size 11 and here are the elements of the array. We can see all the elements are repeated except one, which is 7. So we will try to find out 7 by using the programming, and we will be using XOR. So what basically XOR does is, when the bits are same, the bits are 1 1 or the bits are 0 0, it returns 0, and if the bits are different, if the bits are 1 0 or 0 1, it will return 1. So if we cut 1 and 1, here we should get 0, and here we should get 1, and here we should also get 0, here also we should get 0. If we see the result is 0 1 0 0. That's what we should have got, and that's the result we are getting. So how we are using this XOR in our program, which is to find a unique element in the array. So if we XOR any two elements, and if we XOR all the elements together, so any two elements which are similar will give us 0. So we can see the 5 elements which are repeated twice will return 0, and the element which will remain, which is basically 7, that will remain as our answer. Let's see the flowchart of our program. How are we going to code it? We will start and then store the size, which is the array size, in our counter C. So register C, which we are naming it here as counter. So we will check C. If C is not equal to 0, like the elements are still remaining, then we proceed and store that current element in register B, and then we A XOR B. So A will be storing the previous XOR result with all the elements, and after A XOR B, we will increase the memory location and the counter will also be decreased. But if the counter becomes 0, then we will store the result at 1120 memory location and end the program. Let's see in GNU simulator how we are going to store the data and results. So at memory location 1000, we have size of array, which is 11, and on the next 11 memory location, which are 1001 to 1011, we have 11 elements which are given here, and you can see only 7 is unique. That's the same array which we saw in the previous slides. So let me explain the code, and this code is done using the GNU simulator 8085. So first we are storing the memory location, the data at memory location in C. Here we are moving the data from 1000, which was the size of array. We can see 11 at 1000. We are storing it at C in the register C. We have done XOR A, which is to set the accumulator to 0. So if we XOR any elements ahead, it doesn't give us the wrong result. Then we increase the memory location to get the elements of array. Then we use a label loop, which will be used to jump, and then we move the data at memory location in the register B, and we do A XOR B, XRAB, which is the A XOR B. And A XOR B, what does it give us? A store the previous results, which is basically 0 in the first iteration, and 0 XOR the first element will be the first element. Now we increase the memory location and decrease the counter. So if the jump to node 0, so if the counter is not 0 still, then we jump to loop, and which is this label, and we move ahead, we jump here and we move ahead in the memory location. We moved here, and then we are storing again the data at memory location to B, and we are doing the same thing. So at the end, we are, if the counter becomes 0, then we are not jumping to loop, and we end the program after storing the data at 1120. So let's see the result. So the result is stored at 1120, and the data is 7, which we should have got. So that's all from my side. Thank you.